Hi guys, okay, I am branching out. This is AQA, Further Maths. This is my first paper. This is the specimen paper 1, guys. It is non-calculator, and off we go. Okay, so here's a circle the value of m. Okay, the answer, guys, is 3. I'll tell you why. This is, if you like, y to the 6 times y to the 1. So 6 plus 1, remember you add the powers of the indices, gives you 7. And it's 7 minus what gives you 4. So 7 minus m equals 4. It's only 1 mark, guys. You don't have to show any working. But it's 3, because 7 minus 3 is 4. Fine. Work out the value of n. Similar situation here, guys. What plus 5 equals 5? Well, n has to be 0. So, I don't know. Maybe that's a bit of a mean question at the start. But, yeah. N equals 0. Okay. 1c. C to the 5 to the power of p equals c squared to the power of 6. So 2 marks, guys. I will do some working here. This is c to the 5p. We multiply the powers. When you do a power to another power, you multiply the powers. That equals c to the power of, multiply these powers, 2 times 6 is 12. So I have 5p equals 12. If c to the power of this equals c to the power of that, then the powers must be equal. So 5p equals 12, and then p is equal to 12 over 5. You can put your answer there if you want, but that's the answer. You can write 2.4, guys, if you want to, but again, 12 over 5 is perfectly fine. Question 2. Solve this. Okay, easiest thing to do, guys, is cube both sides. A bit like when you want to get rid of a square root, you square both sides. When you want to get rid of a cube root, you cube both sides. So cube this, I get 7x minus 13. It gets rid of the cube root. And then cube the right gives you 8. So now I have 7x equals 21 because I add the 13 to the 8. And then I do x is equal to 21 divided by 7, which is 3. Okay, nice start. Question 3. This is equivalent, guys. The kind of equal sign with three lines means these sides are equivalent. When that is true, when the left and the right are equivalent, that means it's true for all x values, not just a given x value. So it's slightly different to an equation. But when we have that, we can do this thing where we equate the coefficients of x with the coefficients of x on the left with the coefficients of x on the right, and the constants on the left with the constants on the right. So I'll show you what I mean in a second. So let's first multiply this out. This gives me 3 times 2, 6ax minus 3a. That's just this times this and this times this, plus 4ax plus 20. That's this times this and this times this. And this is equivalent to 60x plus b. Okay, I'll collect these terms here, guys, because it's 6ax plus 4ax is 10ax. So I have 10ax minus 3a plus 20 is equivalent to 60x plus b. Okay, so what we can do, guys, is we can equate the coefficients. So what I mean by that is whatever comes before x on the left, 10a, has to equal 60, because the term with x on the left has to equal the term with x on the right. And the rest, the constants, if you like, those have to be equal. So I can make 2 equations. So I can say the blue equals the blue. So 10a equals 60, which means a is equal to 6. That's pretty easy. And then this one, minus 3a plus 20 equals b. We know a is 6, so minus 3 times 6 plus 20 equals b. Minus 3 times 6 is minus 18, plus 20 equals b, and then b is equal to 2. Okay, so once you know, guys, to equate coefficients, nice easy question. You can write it down here, guys, obviously 6 and 2. Question 4. ABC is a straight line with AB to BC is 5 to 2. Okay, so that means, guys, AB to BC is 5 to 2. Now, I like to, guys, draw some triangles here. So if I go from here to here, that is Okay, and hang on, let me draw another one from here to, here to here. Okay, let's just assume that's a straight line, guys. So what we have is, if that's 5 to 2, then this must be 5 to 2, and this must be 5 to 2. The horizontal ratios must be the same, and the vertical ratios must be the same. So just keep that in mind. Now I'm going to actually find this horizontal distance. This horizontal distance, if I look at the 3 and the 5 to get from here to here, this distance must be 2. And then to get from here to here, I actually don't know what it is. Let's just call it x for now. Okay, then this distance to get from 7 to 5.5 or 5.5 to 7, let's just keep it positive, guys, because it's like a distance. This distance is going to be 1.5. And then this distance, I don't know what it is. Let's call it y. Okay, I actually find these questions quite tricky, guys. So yeah, this is not an easy question. Okay, now essentially what happens is, guys, this ratio, this ratio 5 to 2 must be the same as this ratio 1.5 to y. So 1.5 to y must equal 5 to 2, or y to 1.5 must equal 2 to 5. So try and get your head around what's happening here, guys. This ratio, this length to this length, must be 2 to 5 because the vertical lengths are in the same ratio and the horizontal lengths are in the same ratio, both 2 to 5. Now once you've this, you can, I think it's easier if you just turn it into a fraction, guys, to solve the ratio. So you get y over 15 equals, sorry, not over 15, what am I doing? Y over 1.5 equals 2 over 5. And then you get y is equal to 2 times 1.5, which is 3 over 5, or 0.6. So y is 0.6. Let's put it in, 0.6. Okay, similarly, x to 2, let's say, x to 2 must equal 2 to 5. 2 to 5. And again, I'll just do, guys, x over 2 equals 2 over 5. X equals 2 times 2, which is 4 over 5, which equals 0.8. Now that's not the answer, guys. I need the coordinate. So to get the coordinate, to get c, I need to, well, let's do the x first. I need to add 0.8. So this is x equals 0.8. I need to add 0.8 to the 5. So that gives me 5.8. And I need to subtract 0.6 from the 5.5, which gives me 4.9. So let me just write here exactly what I did there, guys. I wrote 5 plus 0.8 gives me this. That's my 5.8. And I did 5.5 minus, because remember, guys, I'm going down, minus 0.6 is 4.9. So answer is 5.8, 4.9. And then obviously, yeah, write it here, 5.8, 4.9. Okay. Question 5. Why is this? Work out dy dx. Okay, so first thing to do, guys, is to write this as just powers of x. So this is y is equal to 2x to the 10 minus, and we change this 3 over x squared to 3x to the minus 2. We want the power above the line, and guys, if I have a power underneath the line and I want it above the line, I just make it a negative power. Okay, dy dx then equals, I just use my power rule. I do 10 times 2, power times coefficient, which is 20, x, and I subtract 1 from the 10, so I get 9. Similarly here, I do minus 2 times minus 3, that'll give me a plus 6, be careful, guys, plus 6x, and be very careful here, it's minus 2 minus 1, which is minus 3, and that's it. You can write it as 20x to the 9 plus 6 over x cubed if you want, but that's absolutely fine. Question 6, simplify fully this. Okay, so these questions, guys, usually involve some kind of factorizing and then cancelling. So let's do that. So first we will factorize. Let's take out the common factors in the numerator. So numbers, what goes into 15 and 5? Well, 5. What letters are common here? Well, there's an X and a Y here, and there's an X and a Y here. So I'm going to take out an X and a Y. I can only take out one because there's only one Y here and only one X here. If I take out XY, what's left here? Well, I need the 3 to give me the 15. And I need another X to give me the X squared when I multiply. And here I need another Y, and it's just 1. So it's like 1Y or just minus Y. Okay, then we'll do the same with the denominator. We will factorize the denominator a little bit easier. We can only take out the 3, and then in here goes, sorry, what am I saying? The 4. Take out the 4, and then in here goes 3x minus y, which I was kind of expecting because look, we have 3x minus y and 3x minus y. That cancels with that, and we're left with just 5xy over 4. Okay, that is question 6. Question 7. ABCD is a rhombus with side length 8. By the way, rhombus, guys, is 4 equal sides. So if that's 8, so is that, so is that, and so is that. I'm not sure if we will need that. Probably will, but it's important to work out the area of the rhombus. Give your answer in this form. Okay, so I don't think I know the formula for the area of a rhombus. There's a base times height formula that I could deal with, guys, maybe. But what they want you to do really is half this. If you half it, now I've got 2 triangles, so I'll just get the area of the triangle and double it. So let's do that. I'll write area of the, let's do area of the triangle. Area of the triangle formula is a half AB sine C, where A and B are 2 adjacent sides, these 2 sides here, and C is the angle between them. So this area is equal to a half 8 times 8, that's right, 8 times 8 like this, and then sine 60 degrees. Okay, so this question, guys, is testing, well, it's testing a few things, but one of them is that you know what sine 60 is without a calculator. So 8 times 8 is 64. 64 divided by 2 is 32. So it's 32 times sine 60. Now, guys, sine 60, if you've ever seen me do my exact triangles, sine 60 we get from this triangle here. This is an equilateral triangle that I've halved, which means this is 60. This is 30, by the way. I won't need it, but it's 30. I make the sides 2, and I've halved this one, so it's 1, and then Pythagoras' theorem is 3. So, guys, this, I'm not teaching you this right now, but this triangle, if you haven't seen it, this is how I get a sine of 60. There's the other way to do it is by writing out the table, but one way or another, you need to know what the sine of 60 is without a calculator. It is opposite over hypotenuse root 3 over 2. So it's root 3 over 2, which is equal to 16 root 3. But that's the area of the triangle. The rhombus has 2 triangles. So I'll just write area of, let's just write rhombus, guys. Area of rhombus is equal to 2 times 16 root 3, which is back to, guys, 32. 32 root 3. Okay, so actually, guys, there is a formula for area of a rhombus if you want. It's just instead of a half AB sin C, it's just AB sin C for this reason, because you halve it and then you double it. Okay, so that's the answer. That is question 7. Question 8. The curve y equals this has a maximum at minus 113 and a minimum at 2 minus 14. It intersects the y-axis at n. There's 3 x-intercepts. Draw the curve and label your sketch. Okay, so we don't need the x-intercepts because it didn't tell us we had to label them. What we do need is the y-intercept, and the y-intercept is when x equals 0. When x equals 0, y is equal to, these all just become 0, 0, 0, and you're just left with 6. So y is equal to 6, so that means n is 0, 6. Okay, so we're going to sketch this. We have our maximum at minus 113. Let's go minus 1. Let's say that's minus 1, and let's just say 13 is about here. Minus 113. Then we have our n is at 0, 6, so that would be 0, a bit less than halfway. I don't know, let's say there. By the way, this is L, and this is N, our y-intercept. And then 2 minus 14, let's say that's 1, that's 2, minus 14 needs to be, I don't know, somewhere a bit lower than L, so something like that. Okay. Now, this is our maximum and this is our minimum. He hasn't given us a domain, so I'm just going to draw this like this. So a cubic, guys, by the way, a positive cubic goes up, then down, then up. If it was negative, it would go down, then up, then down, but it's positive. So it goes up, down, up. And also he's given us the fact that this is the max and this is the min. So that's L, N, and that's M. Okay, so it's going to go up. I don't know exactly where across the x-axis, but up here like this, turns, that's the maximum, goes through this, like so, down here like this, turns, something like that. It's not a great drawing, but there you go. That's a cubic. So, as long as you have the points, the correct shape. I think the 3 marks in the mark scheme, guys, are for the 3 points labeled, correct shape, and the fact that it crosses the x-axis at 3 places, once to the left and twice to the right of the y-axis. Okay, question 9. Okay, let me zoom out a second. Okay, let's just prove that this is a diameter. Okay, so it says A, B, C, D are points on a circle. Prove that AC is the diameter. Okay, it's the diameter if, so I will zoom out, guys. It is the diameter if, now how can we prove that is the diameter? Well, it's the diameter if CBA, this angle here, is a right angle. So if that is a right angle, then we know it is a diameter, because we know the angle in the semicircle from the circle theorems is a right angle. So diameter if angle, let's do angle CBA, or ABC I could do, if angle ABC is 90 degrees. Okay, so that's the first step to kind of think, and we will write that down. We're writing that down to say that's what we're trying to do. That's what we're trying to prove. Okay, so what else do I have? Well, I have, and let's call it theta, guys. And I'm going to call this, let's just put in brackets, theta is 90 degrees. So I know that x plus 4x plus theta, I'll write here, guys, just so we can all see it, but obviously you write below. So x plus 4x plus theta equals 180 degrees. We know that because that's a triangle. This plus this plus this is 180 degrees. Okay, so that means 5x plus theta equals 180 degrees. Okay, we also know opposite sides in a cyclic quadrilateral add up to 180. So also, let's write also, x plus 2x plus 4x plus 3x equals 180. That is because this angle plus this angle add up to 180 because they're opposite angles in a cyclic quadrilateral, which is this quadrilateral that touches the circle at the 4 points. Okay, this is 3x, 6x, 10x. Okay, so 10x is 180, so x is equal to 18. Okay, so if x is equal to 18, let's go back to this guy here. If x is equal to 18, 5x plus theta equals 180. X is 18. 5 times 18 plus theta equals 180. 5 times 18 is 90, so 90 plus theta is 180, which means theta is 180 minus 90, which is 90 degrees. So theta is 90 degrees, therefore theta equals 90 degrees, therefore AC is a diameter. Okay, hope that makes sense, guys. Next question. Question 10. Okay, f of x equals this. Okay, so the minus 1, guys, just note this is literally the reciprocal. So this equals 2 over 9x. So I think they're just writing that to confuse you, but note it is that. It is not the inverse function. That would be different, guys. That would be f minus 1 of x. It's a different thing. Okay, g of x is this. Given that f of a third equals g of a third, work at the value of p. Okay, so easy. We're just going to sub in. We are going to sub in a third into both of these. Okay, so f of a third is equal to 2 over 9 times a third, which is equal to 9 times a third is 3, so that equals 2 over 3. Nice. Okay, g of a third, g of 1/3 is equal to the square root of 1 minus p times a third cubed. Okay, maybe this isn't going to be as easy as I thought, guys. P times a third cubed because x is a third. Okay, this is equal to the square root of 1 minus a third cubed, guys, is actually 1 over 27. So this is p times 1 over 27, which is p over 27. Why? Because a third times a third times a third is 1 times 1 times 1 over 3 times 3 times 3, which is 1 over 27. Okay, now he's saying these two things equal. So let's do exactly what he says. We'll form this equation. 1 square root of 1 minus, I'll do p over 27, equals 2/3, because he says they are equal. Fine. Need to get rid of the square root. Square both sides. 1 minus p over 27 equals 4 over 9. Okay, I don't love, guys, I don't love fractions, so, well, I do love fractions, but I don't like these denominators. So what I'll do is I will multiply across by 27. If I multiply by 27, it'll remove the 9. So this times 27, this times 27 is just p, and this times 27, I'll just do it, guys, is 4 over 9 times 27, like this, and then 9 into 9 goes once, 9 into 27 goes 3 times. So this is equal to 27 minus p is equal to 12. 4 times 3 is 12. And then we can just put the p over here, guys, add p to this side and subtract 12 from this side. 27 minus 12 is 15. So answer, p equals 15. Okay, question 11. Okay, a circle, center C, touches the y-axis at point 0,2. The line y equals k intersects the circle at 1k, 5k. Find the equation of the circle. Okay, so basically we're given this information. Find the equation of the circle. To find the equation of the circle, guys, I need the center and I need the radius, and then I can just sub it into the equation of a circle formula. So, okay, this is 0,2, guys. He says it just touches the y-axis there. So that means that's the tangent, which means this line here is 90 degrees, which means that if this is 0,2, the y-coordinate of this guy is definitely 2. Also, if the line y equals k, if this is horizontal, then this line here would bisect that chord like this, meaning that if this is 1 and this is 5, what's in the middle, the x-coordinate has to be 3, because it's halfway between 1 and 5. 1 plus 5 over 2 is equal to 3. Okay, so the center is 3, 2. Now also, guys, if this is if this is 3, the radius is 3, because this goes from 0, 2, and straight across we get to 3, 2, so the radius is 3. So the equation of the circle is just x minus 3 squared, so it's x minus this squared, plus y minus 2 squared equals 3 squared, which is 9. And that's it. That's question 11. Question 12. Okay, AB is equal to 4, AC is 7, cos of x is minus 2x. Work out the length BC. Okay, this, guys, is just cosine rule. Okay, so cosine rule, we can go. Let us call this not x, I'll call it y. So y squared equals 4 squared plus 7 squared, that's this squared plus this squared, minus 2 times 4 times 7 times cos of x, and cos of x is minus 2/7. So this times minus 2/7, like this. Okay, so y squared equals 16 plus 49, 16 plus 49, minus 2 times 8 times 7 divided by 7. Okay, so this 7, guys, cancels with this 7. And I have minus 2 times 4 is minus 8, times minus 2, minus is plus, so it's just going to be plus 16. 8 times 2 is 16. Okay, and now I have 16 plus 16 plus 49, which is, that would be 49 plus 32, which would be 81. So y squared is 81. Therefore, y is equal to the square root of 81, which is 9. So it's 9 centimeters. Question 13. Rearrange t equals this to make w the subject. Okay, so multiply across. Let's get the w out from under the denominator. So I'll do t w cubed minus 2 equals 3w cubed plus a. Okay, let's get the w cubed's terms together, but I have to multiply out this bracket first. Tw cubed minus 2t equals 3w cubed plus a. Tw cubed minus 3w cubed equals, now I'm going to add the 2t over here, a plus 2t. Take out the w cubed. I get t minus 3 equals a plus 2t. I was going to say finally, but not finally. I need to first divide by t minus 3, so it's a plus 2t divided by t minus 3. And then the finally step is to get the cubed root of this. So that's cubed root of a plus 2t over t minus 3. And that's question 13. Question 14. Rationalize and simplify. Give your answer in this form. Okay, so we need to root 3 minus 7, root 3 plus 1. I need to multiply the top and the bottom by the conjugate of the denominator. So it's root 3 plus 1, sorry, root 3 minus 1 times root 3 minus 1. Now note, guys, these are in brackets. And put these in brackets because you're going to do it the long way. So we do root 3 times root 3 is 3. Root 3 times minus 1 is minus root 3. Minus 7 times root 3 is minus 7 root 3. Minus 7 times minus 1 is plus 7. And that is all divided by root 3 times root 3 is 3. Root 3 times minus 1 is minus root 3. 1 times root 3 is plus root 3. And 1 times minus 1 is minus 1. Now you'll notice, and you may have seen it before, or you may have seen it before you did it, these cancel. So I'm left with 3 plus 7 is 10. Minus root 3 minus 7 root 3 is minus 8 root 3. Divided by 2. 3 minus 1 is 2. And this gives us 5 minus 4 root 3. Because we do 10 divided by 2 is 5. 8 divided by 2 is 4. Okay, that is question 14. Question 15. Point A lies on the curve. X coordinate of A is -4. Show that the equation of the normal to the curve at A is this. Okay, so to find the equation of the normal, we need a point, and we need the gradient. Okay, first let's find the point. We know the x coordinate, we know the x coordinate is -4. He tells us. So x is equal to -4. That means y, I'll do comma, y is equal to -4 squared, plus 5 times -4 plus 8, which is 16 minus 20 plus 8, -4 plus 8 is 4. Okay, so the point is therefore -4, 4. Gradient. Next thing I need is the gradient. Okay, to find the gradient, I do the derivative, right? So if y is equal to x squared plus 5x plus 8, the gradient of the tangent, be careful, gradient of the tangent, we find from the derivative. The derivative is 2x, 2 times 1 is 2, and then subtract 1 from the power, and the 5x just becomes 5, the 8 disappears, the derivative is 2x plus 5. At x equals -4, comma, dy dx equals 2 times -4 plus 5 minus 8 plus 5 is -3. Okay, so now I have the gradient of the tangent, but I want the gradient of the normal. So I'll do m tangent is equal to -3, but m normal is equal to 1/3. Now he wants us to show that the equation of the normal is this. The equation of the normal we will get using the point and this here. So let me just clarify. We're going to use this point and this m. Now you can use, guys, the formula for the equation of the line, y equals mx plus c, or my preferred one is y minus y1 equals m into x minus x1. Okay, we sub in the point, so it's y minus 4, because it's y1, this is your x1, y1, equals m, which is a third, into x minus -4, which is actually plus 4. Okay, now he wants it in this form, 3y equals x plus 16. I'm just going to multiply across by 3 here, guys. Watch this. I do 3 times y, 3y, 3 times -4, minus 12. The third disappears, and I get x plus 4, and then I just do 3y equals x plus 4 plus 12 plus 16, which is what he wanted, Q, E, D. Okay, so that's it, guys. Feel free here to use or y equals mx plus c, and then sub in the x and y to find c, and you'll get the same thing. Okay, 15b. The normal at A also intersects the curve at B. Work out the coordinates of B. Okay, so if they intersect, guys, I have to solve them simultaneously. So it's x squared plus 5x plus 8. So I'll just leave that there. It's x squared plus, what did I say, 5x plus 8. X squared plus 5x plus 8 must equal, well, sorry, it's not going to equal that. So this is y equals this, and here 3y equals x plus 16. So this is like simultaneous equations, guys, but one of them is a quadratic. So I could, let me think what I will do. I think the best thing to do in this situation, guys, is to just divide this by 3 here. So I get y is equal to x plus 16 over 3. So now I'll put x plus 16 over 3 equal to this, x squared plus 5x plus 8. Multiply across by this 3, guys, to remove the denominator. So x plus 16 equals 3x squared. Don't forget to multiply this by 3. So this is 15x, and this is 24. Let's make all this equal to 0. I have 3x squared plus 14x, because I'll subtract this x, and I have 24 minus 16, which is 8. Okay, I have to now solve this equation, guys. So sorry, he only wants the x coordinate, so good, I don't need the y. I need to factorize this. I'll do it, guys, the kind of longer way over here, where I do a times c is equal to 24. Factors of 24 to give me 14. It's definitely going to be 12 and 2. So then I do 3x squared plus 12x plus 2x plus 8 equals 0. Factorize these two, 3x, x plus 4 plus 2x plus 4, giving me, this is 0, giving me x plus 4 when I take it out of both terms, and 3x plus 2. So these are the factors. Therefore, x plus 4 equals 0, or 3x plus 2 equals 0. In this situation, x is negative 4. In this situation, 3x is negative 2, and x is negative 2/3. Now, which is the answer? Well, he says here the normal also intersects the curve at B. Now, if he says also, well, we already had here the normal of the curve. It already intersected it at minus 4. That's what the normal does. It intersects the curve at the normal. So this is minus 4. So the other one, where he says also intersects the curve at B, the x coordinate of B has to be negative 2/3. So just try to keep it in the lines, guys. I don't think they give us enough space there, but make your answer clear. Okay, that's question 15. Question 16. The coefficient of the x to the 4 term in the expansion of this is 60. Work out the possible values of a. Okay, we need, guys, Pascal's triangle. I will do it fairly quickly. It is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. This is the one I want, guys, because it has my 6 here right after the 1, and this is to the power of 6 here. Okay, so the way I do it, the way I like to do this, guys, is I go 1 bracket bracket. So this thing expanded, this 2x plus a to the power of 6 is equal to 1 bracket bracket plus 6 bracket bracket plus 15 bracket bracket plus 20 bracket bracket. Now I might stop there. This will be dot dot dot, but once you know I'm only looking for the x to the 4 term, so this is the first bracket's always 2x, so 2x 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 2x, and the next bracket is always a. These powers go down. It's 6 5 4 3 2 1 0, and these ones go up from 0 1 2, 3. Now it's dot, dot, dot. I'm going to stop there because I have got the term I want. It is this term here, because this is the one that has x to the power 4 in it. Now he says the coefficient of this equals 60. So when I expand this term out, I get 15. Hang on. This 15, be very careful guys, the 2 to the power of 4 is 16. So it's 15 times 16 times a squared. And then there's an x to the power of 4 when I expand out this. But he says the coefficient of x to the power of 4. So I'm actually going to remove this, because just the coefficient of x to the power 4, which is what comes before x to the power 4, equals 60. So I can just say this equals 60. And now I can solve this. I'm going to divide both sides by 15. So 16a squared is equal to 4. And then let's just divide by 16. A squared is equal to 4 over 16, which is a quarter. And then if this is a quarter, a has to equal plus or minus the square root of a quarter. And the square root of a quarter, guys, is root 1 is 1. Root 4 is 2. So it's just a half. So it's plus or minus a half. Okay, that's question 16. Question 17. Solve the simultaneous equations. Okay, so guys, hopefully we know how to do these. I am going to, just looking at these, I like to look at which coefficients are the same. So this guy has a c similar to him, and this guy has a b similar to him. So I think let's do the first and the last first. So this is 2a plus b minus c equals 8, and 6a plus 3b plus c equals 0. We add them because the c's are the ones we're getting rid of, and they have different signs. So different signs we add. Add these two, 8a, add this, 4b, add this, that disappears. 8 plus 0 is 8. I think, guys, in this situation, divide by 4. 2a plus b equals 2. Okay, that's the first, that's the c removed here. Okay, now I want to remove the c in 2 more equations. So let's look at, sorry, yeah, guys, I have to do this. Let's do these 2. So I do the first and the last. Let's do the second and the last. Okay, so I will do, but yeah, sorry, I do need to change the, I need to change the c here. Okay, so I have 4a minus 3b minus 2c equals -9. And I'm going to multiply by 2 here. So 12a plus 6b plus 2c equals 0. I've multiplied everything by 2. Line across. Again, guys, I'm adding because it's different signs. This gives me 16a. This gives me 3b. And this gives me -9. Okay. Then I look at these 2 equations here. This guy and this guy. So let's get the b's the same here, guys. So I'll make this, I will make this multiplied by 3. 6a plus 3b equals 6, and 16a plus 3b equals -9. Let's put that, this one, on top, and I'll put this one below because we're going to subtract. Equals 6. Okay, it says, guys, same signs subtract. Sorry, it doesn't say that. I'm saying that. These are the same signs. Subtract them, so that disappears. 16a minus 6a is 10a. So I have 10a. And -9 minus 6 is -15. So a is equal to -15 over 10, which is -3 over 2. Okay, so my a is -3 over 2. Then I'll put that a back into an equation, guys, probably this one, the easiest one to put it into. So I'll go over here, I'll say 2 times minus 3 over 2. 2a plus b equals 2. The 2's cancel here, so this is just minus 3 plus b equals 2. So b is equal to 5. And then we go to the final step, which is we go back to an original equation that has a, b, and c in it. I think this one. To get c, I'm going to say 2, well, let's just write it out. 2a plus b minus c equals 8. 2 times minus 3 over 2 plus b, which is 5, minus c is equal to 8. And this becomes, again, these cancel, minus 3 plus 5 minus c equals 8. Let's go up here. Minus 2, sorry, plus 2. 2 minus 3 plus 5 is 2. 2 minus c equals 8. I am going to put the c over here, add the c here, subtract the 8 there, minus 6. So I get a is minus 3 over 2, b is 5, and c is negative 6. Okay, these ones, guys, they're not hard. They're always the same. Well, nearly always the same. But it's easy to make mistakes, so just be careful. Okay, that is question 17. Question 18. Solve x to the power of negative 2 over 3 is equal to this. Okay, first thing I'm going to do, guys, is I'm going to change that mixed number, which I don't like. I don't like mixed numbers, guys, into an improper fraction. So 4 times 12 is 48, plus 1 is 49. So it's 49 over 4. Okay, next thing I like to do, guys, there's a few different ways you can solve this problem, but what I like to do is I like to raise this to the power that will give me just x to the power of 1. Now, if I raise this to negative 3 over 2, which is basically the reciprocal, is not 2 over 3, 3 over 2. The reciprocal, this will give me 1, because look, if I do negative 2/3 times negative 3 over 2, minus minus plus, and then 2 times 3 is 6, 3 times 2 is 6, they cancel, you're left with x to the power of 1. So then I obviously have to do the same to the right, so it's 49 over 4 to the power of negative 3 over 2. Then I have to deal with the negative power here. So this is just going to be x, the left is x, and this is going to be negative power, so I flip it, it's the reciprocal, is 4 over 49 to the power of the positive power, which is 3 over 2. So now I just need to do 4 over 49 to the power of 3 over 2. If you recall, guys, flower power is the square root cubed. So that, let's just go up here, is equal to the square root of 4 is 2. And so it's 2 cubed over the square root of 49 is, so guys, let me just clarify what I'm doing here. So it's 4 to the 3 over 2 over 49 to the 3 over 2. So you do the power 4 to the numerator to the power and the denominator to the power. Now this is the square root, because the 2 is at the bottom of the fraction, so that's the root. So it's the square root of 4, which is 2 cubed, and it's the square root of 49, which is 7 cubed. So now it's just 2 cubed over 7 cubed. 2 cubed is 8. 7 cubed, guys, is one of those ones that, well, you're not expected to know that, but it's 3. Well, you're expected to know how to figure it out because this is a non-calculator. Obviously, guys, you can just do 7 times 7 is 49 times 7. Do it like this: 63. Put down the 3, carry the 6. 7 4 is 28 plus 6 is 34. So it's 3 4 3. So x is equal to 8 over 3 4 3. Okay, question 19. F of x equals this. Use differentiation to show that it is increasing for all values of x. Okay, so guys, firstly, remember the derivative, f dash of x, the derivative, is the gradient of the function. So it tells you the gradient of the function, and the gradient tells you if it's increasing or decreasing. If the gradient is positive, it is increasing. This, guys, is an increasing function because it's going up for all values of x. And it's not constant, like a straight line would be. It would have a constant gradient. The gradient is changing, but it's increasing. A decreasing function would be like, well, like this. this is decreasing. So if it's increasing, f dash of x is greater than 0. So for all values of x, for all x, if it is increasing. Now he's saying to show that it's increasing. So let's first find f dash of x and show that this is greater than 0 for all values of x. Okay, f dash of x multiplied by the power. 6 times 2 is 6. Subtract 1 from the power, so it's 6x squared. 2 times minus 12 is minus 24. Subtract 1 from the power is x. This becomes 25. And this becomes 0. So it's 6x squared minus 24x plus 25. Okay, so one thing I could do, guys, is my first thought would be to actually, if I could factorize this and show that it's a square, then that shows that it's greater than 0 because a square number is greater than 0, apart from 0 itself. But this doesn't actually square because 6 is not a square number. So next thought is to complete the square. If I complete the square, I will find the minimum value of this. Remember, when you complete the square, the minimum value is the, well, it's the k bit at the end. It's the constant at the end of the completing the square. If that's bigger than 0, then we're good. We have showed it's greater than 0. So let me explain what I mean. We will complete the square. So let's first, I like to take out the 6 out of these first two. So this is x squared minus 4x, and the plus 25 is over here. So I've just taken out 6 out of the first two. Then I complete the square of what's in the bracket here. I bring in a square bracket. I then half the 4, so it's x minus 2 squared. And I have to subtract 2 squared, which is 4. If you don't know how to do this, guys, you need to go and learn it. This is, I've completed the square, and then plus 25. And then this becomes, multiply out the square bracket, 6 times x minus 2 squared minus 4. Sorry, nearly made a mistake. I'm always telling kids not to make. 6 times 4 is minus 24, and then plus 25, which gives us 6x minus 2 squared plus 1. Now this 1, this is the thing I was trying to explain, guys. This 1 is the minimum value of f dash of x. So you do want to write a kind of line at the end here. Minimum value for f dash of x is 1. Therefore f dash of x is greater than 0 for all x. Okay, for all x values. Done. Okay, next question. Question 20. Show that 2 cos squared theta is equivalent to 2 minus 2 sine squared theta. Okay, so that means, guys, we're going to take the left-hand side and show that it equals to the right-hand side. We can't, when you have this equivalent sign, guys, you can't kind of work across it the way you would if you were solving an equation. So we just need to make this equal to this. You can actually make the right-hand side equal to the left-hand side, but let's just do the left-hand side. So we start with our formula, which is from the formula sheet, cos squared theta plus sine squared theta equals 1. That's the Pythagorean identity. So this plus this equals 1. And then that means cos squared theta equals 1 minus sine squared theta. We just subtract the sine squared theta. And then 2 cos squared theta, if I multiply the left hand side by 2, I'll multiply the right hand side by 2. So this is 2 minus 2 sine squared theta. So therefore you've shown it. I'll just write QED, done. Okay, then he says hence, so he's kind of helping you to solve this trig equation, guys, by making you do that. So hence solve this plus this equals this. So he's giving us the hint to change the 2 cos squared theta into 2 minus 2 sine squared theta plus, so this turns into this, and then we've plus 3 sine theta equals 3. I'm actually going to straight away, guys, go minus 3 equals 0. Okay, now we have what I like to call, guys, is a quadratic in disguise. So this is going to be minus 2 sine squared theta plus 3 sine theta. Minus 3 plus 2 is minus 1 equals 0. I'm going to change all the signs, guys. I prefer working with a positive x squared term. So it's 2 sine squared theta minus, sorry guys, I just realized I did not write sine properly there. So minus 3 sine theta plus 1 equals 0. Okay, I'm going to factorize this, guys. It is the factors of, let's just do my a times c thing, guys. A times c is 2 times 1, which is 2. Factors of 2 to give me negative 3 are going to be negative 2 and negative 1. So this is 2 sine squared theta minus 2 sine theta minus sine theta plus 1 equals 0. You can, guys, sometimes I advise calling sine squared, calling sine theta x, but this works the same. So it's 2 sine theta into sine theta minus 1, and then minus sine theta, minus 1 into sine theta minus 1. Okay, this is me factorizing, guys. So just if you're not able to factorize a quadratic, go and learn it. You definitely need to know how to do that. 2 sine theta minus 1 times sine theta minus 1 equals 0. Okay, then I really feel, guys, they don't give me much space here, but let's go down here. So this means that 2 sine theta minus 1 equals 0, or I just don't like, guys, having this not in a line. Okay, so this, or sine theta minus 1 equals 0, 2 sine theta equals 1, and sine theta equals a half, or sine theta equals 1. Now, we're going to solve these separately, guys. Sine theta equals a half. So where does sine theta equal a half? Well, the way I do it, guys, is I say my acute angle, we need to know what the inverse sine of a half is, everyone. It's 30 degrees. And we need to know what the inverse sine of 1 is. It's 90. So here, theta is equal to 90. This one's the only solution, 90. And for this one, I like to do my cast diagram. So a very quick C-A-S-T. Sine is positive, so it's in this quadrant and this quadrant. 30 degrees is here. This is 30. And then this one over here, well, the acute angle here must be 30, which means my angles are here, theta is equal to 30, and this guy is 150, guys. So that's 30 in the all quadrant, and this one is 150. So that's 30 and 150 degrees. So my three solutions are 30 degrees, 30 degrees, 90 degrees, which is this one here, and 150 degrees. Okay, and that's it, guys. That is the paper done. Obviously that last question's difficult. It is supposed to be, but there you go, and not made easier by the fact that they don't give you a lot of space, but there you go. All right, okay, guys, that's my first AQA Further Maths paper done. I will see you for paper 2, and I'll continue doing the next questions. All the best.